Stanford University.
Okay, well, welcome then to Stanford CS193P. This is fall of 2010 quarter. Make sure you're on the right airplane here before we leave the gate. This is developing applications for iOS. Okay, so that means iPod Touch, iPhone, iPad, all the versions of the iPhone basically. But we're going to focus mostly on iOS 4, which is the latest version. My name is Paul Hegarty. I taught the course last quarter, and I'll be your lecturer for all the main Tuesday, Thursday lectures this whole quarter. So what are we going to talk about today? Unfortunately, we have some logistics at the beginning to cover about how the lectures work and how I'm going to communicate to you a little bit about the homework, final project, and also requirements, because there are some requirements that you have to meet in order to really be successful in this class. Then I'm going to do a brief overview of iOS. I don't want to spend too much time on that because we're going to spend all quarter going into it in depth, but I just want to give you a feel for what it's about. I'm not going to talk really about iOS from an end user standpoint. So if you don't own an iPhone or an iPad and you've never seen it, I encourage you to go watch Apple's TV commercials or go down to an Apple store or borrow a friend's, because I'm going to assume from the beginning that you've seen it, you've seen applications running on iOS, and we're going to talk about how to make that happen. We're going to talk about building the apps. We're not going to talk about the user experience, or at least I'm not going to in the lectures. And then last, I'm going to start the actual course content talking about an object-oriented design concept called Model View Controller, which is just absolutely fundamental to being successful as an iOS developer. If you don't get Model View Controller and you start building your apps in kind of a wonky way that's not using this paradigm, you will be going downhill fast. Okay, it's going to be very difficult to be successful, especially as we start building more complicated versions of the apps later in the quarter. So logistics. The lectures work like this. Okay, there's 2 main lectures a week, and I break them up into Tuesday's lecture. I'm going to basically talk at you, show you some nice slides, go through some concepts, show you a lot of code, but on slides. But I'm going to tell you what we're going to learn that week. Then on Thursday, mostly, I'm going to show you. So I'm going to show you demos, real demos. You know, I'm going to start from scratch almost all the time. We'll build demos that are demonstrating what I talked about basically on Tuesday. And then after class on Thursday, I'm going to assign your homework, and you're going to do it. Okay, you're going to do a homework assignment that is about whatever the concepts are that week. So it's not like I'm using your homework to teach you additional stuff or something like that. I'm basically going to show you everything 3 times. I'm going to tell you about it, show it to you, and ask you to do it. Okay? So by the time you've seen the same concept in those 3 ways, hopefully you'll have it mastered. Then there's another lecture, which is this Friday TA section. It's an optional lecture. Now, what's going on at that lecture? Some weeks there might be nothing at the lecture, but hopefully the vast majority of them will have something for you. Sometimes it's practical matters, like this Friday. We're going to show you how to use the debugger, okay, which you might say, wow, it'd be nice to cover in the main lecture, and it would, but if you don't go to Friday's section, it is optional. You could go learn the debugger with Apple's online doc, etc. But it's a real nice, jump start to show up on Friday and get to see how to use the lecture. So some of the lectures are like that, kind of practical things that will make things go a little easier and faster for you. The second kind of Friday lecture is Kleiner Perkins, which is a local venture capital fund. You've probably heard of them. They are very graciously sponsoring a few lectures where they're going to have one of their entrepreneurs of one of their iPhone. They have a fund that funds iPhone and iPad development called the iFund. So they'll maybe have one of their entrepreneurs that got funded come in and talk about their experience developing a real app for money that was venture funded. Or maybe some of the partners at the venture capital fund might come in and talk about, hey, here's what we're looking for when we're trying to decide whether to fund something out of iFund. So for any of you who have an entrepreneurial bent, those will be great. And then we might also have a couple of guest lectures. Maybe someone from Apple come and talk about some particular topic, maybe like how to get your app on the App Store, what the actual process looks like, what screens you have to fill out, what information. So that might be kind of fun as well. So communication, the way that I'm going to communicate with you is via cs193p.stanford.edu. Okay, so you definitely want to go there. I will post every lecture, hopefully right before each lecture, like I did today, so that if you have a laptop, you can download that PDF file and follow along. Also, the demo code, all the demo code I do, I'll post that as well, so that way you can just download it and build it. And the homework. And the homework assignments are fairly large write-ups. These are not just like, one page, do this. They have a lot of information in them, and so I'll be posting those as well. And there's not a lot of class announcements too much in this class, but what few there will be, you will see on that website as well. Things like what's happening at the Friday sections, those kind of announcements you'll see there. All right, the homework. The homework takes 1 week. It's assigned after lecture on Thursday, as I said. It's always due the next Wednesday at 11:59 p.m., just to be clear. End of the day Wednesday means Wednesday, Pacific time. Okay. The homework assignments are individual work only. So no teams, no working together. I really want you to go through the experience of fighting through, understanding where the objects go, what the boundaries should be, what's in the SDK, searching through the SDK to find a method that you want, because that's what it's like to program in a large program system. It's so large, nobody knows it all in their head, so you have to be able to go through the documentation, etc. That we should cover on Friday as well, kind of how to navigate the documentation. So that's the homework. The final project, 3 weeks to work on it. There will be no homework at that during those 3 weeks. It requires my approval for the proposal to get the right scope. Some teams of 2 might be allowed for that. And the reason sometimes I'll allow that is someone or 2 people have a great idea for a final project, but it's just too big for one person to do in 3 weeks. But it can be easily divided up between the 2 people, and it's be easy to show who did what. And that's important, obviously, in terms of evaluating your mastery of the class material, is to know who does what on the final project. So some teams of 2, but that does require my approval. And the last thing to note is that a keynote presentation will be required. It's not like an optional thing. At the final exam period of this class, you're each going to get up right here, and you're going to give a keynote presentation about your final project. And you can imagine that there's a venture capitalist sitting in the room, and you got 3 minutes of their time because they're on their way to the airport, and you're trying to sell them your idea, okay? Or if you're not interested in that, you still want to give us a complete understanding what it is your application does, okay? Does that make sense? So that is required, not optional. Okay, now, what is required to be successful in this class? First, you have to have a Mac. Okay, the development environment only runs on a Mac. People have said, "Oh, can I have a Windows machine and emulate the Mac?" I've seen people have a lot of problems with that. I recommend getting a Mac, not only a Mac, an Intel-based Mac running Snow Leopard. Snow Leopard is required for the latest SDK. So that's something you need to line up. Now, Stanford students, the cluster computers, I'm told, do not have the SDK on them, and you can't be installed, so you cannot use those computers. So you got to go find a Mac somewhere. I see an awful lot of laptops out here, so hopefully that's not going to be too much of a problem. As far as iOS hardware, like an iPhone or an iPod Touch or an iPad, that is not required for the homeworks. Okay, I don't require you to run any of your 7 homeworks on the hardware. However, it is required for the final project. Okay, so I have some loaners. They're iPod Touches. They're 2nd generation, so they'll be running iOS 4, but they're not the latest ones, so they don't have camera and that kind of stuff in them. So I can loan those to you if you have no other option. Otherwise, you want to be lining up something if you don't already own a device in the next 7 weeks, because your final project is you're going to have to show it running on the device, on a device. Could be on the iPad, iPhone 4, whatever. Textbook, there's no textbook for this class, but we lean heavily on developer.apple.com. There's a lot of documentation there. Also the development environment, Xcode application where you edit your code, tons of documentation built in there. So that's where that's going to come from. Also, by the way, my lectures, they'll be on iTunes, they'll be on the website. You can go back and refer to them. Again, I put a lot of code in the slides, and obviously in the demo, you'll be able to see how things are used. So it's almost like that's the reference material for you. So prerequisites, object-oriented programming is a hard prerequisite for this course. It is not negotiable. If you have not had significant experience writing object-oriented code, you will struggle in this class because the iOS SDK is entirely object-oriented. Not only that, but to build effective large-scale applications, you've got to understand how to use object-oriented programming. Okay? It's not just, oh yeah, a method, that's like a function, right? If you have that approach to object-oriented programming, you will not be able to build anything complicated that will be debuggable and manageable. So that's a hard requirement. At Stanford, that means CS 106A and B, which my understanding is nowadays one of them in C++ and one's in Java. Is that right? So that's 2 languages. You're going to learn a 3rd language in this course because the iOS SDK does not use either of those 2 languages. But it's always good to learn more languages. CS 107, recommended, just more experience. But 106A and B, if you haven't taken both of those or the equivalent thereof, this course can be a struggle. For example, here I'm listing a bunch of object-oriented terms like class, instance, message, method, instance variable, inheritance, superclass, subclass, protocols. If these don't seem familiar to you or you're like, I think I know what that is, this is going to be trouble, okay? So make sure you know those terms. The iOS 4 SDK. So that is, SDK stands for Software Development Kit. That's basically the big package that is the development environment that we're going to use to develop applications. It's free. You can download it from developer.apple.com right now if you want. It's big, but you can download it for free. But to run on a device, if you want to build an application and run it on an actual device, you need to be a member of a program, capital P program. And there's 2 programs of interest here. One is the iOS Developer University program. Now, all of you Stanford students sitting in this room, you're going to get a free invitation to that. It costs you nothing. Once the enrollment decisions are made, and if you're one of the lucky ones who get in, we will send you an invitation to that. And that will allow you don't really get anything more in terms of downloads, but it allows you to run your program that you build on the device. Okay? If you're watching on iTunes or you're in this room and you're not a Stanford student or you don't make the enrollment and you decide to sit in and audit the class, which is fine by the way, then if you want to run on the device, which you may or may not want to do, like if you're building your final project for yourself, obviously we're not going to be grading it if you're not a student, but if you want to run a device, you can pay $99 a year. And for that $99 a year, you not only get to run a device, but you also can submit your application to the App Store and sell it. And so people complain about $99 a year, but think about it, $99 is actually a pretty good deal considering that's got to cover Apple's costs to review your program and pay you, right? When you sell your program for money, they're issuing you a check or paying you, and so there's overhead for them. So $99 a year, that's a steal. And so that's the difference. If you're in the class, you're welcome to do the $99 a year. It's the same thing. And in fact, for $99 a year, another thing you get, access to betas. So as the beta versions of iOS 4.1.2 or 4.2 or whatever come out, you'll get access to those if you pay your $99 a year. You won't if you're in the University Developer Program. In addition to answering the invite we're going to send you, if you're a Stanford student, you can also submit the device ID of your device. Actually, you're going to have to submit the device ID of your device, and we will approve it. And then there's this whole process that you'll go through to get a certificate that you can put on your phone that basically enables you to run your application. And we'll talk about all that later in the year, okay, in a couple weeks, maybe at a Friday section or something. The university program goes on a quarterly basis, so it's only going to be valid for this quarter, but any code you write at the end of the quarter when this thing shuts off, you can start paying your $99 a year and off you go. It's not like anything happens. It's just that it won't work on the device anymore after the course is over. Okay, so what will I learn in this course? Okay, well, the number one thing you're going to learn is how to build cool apps. Okay, and why do I say the apps are cool on this platform? Well, it's a lot of reasons. One, this is a very powerful development platform. You can build very complex apps with very little effort. Okay, so it's very rewarding as a programmer to put in some effort and whoa, this is really cool. I got this cool app, in a very small amount of work. So it's rewarding in that way. Also, it's very cool to build an app and say, hey, my friend, let me show you my app and bring it out of your pocket. That's cool, as opposed to, oh, okay, well here, I'll give you this CD-ROM, you can go run it on your Windows machine or something like that. Okay, so it's pretty cool that the result of your work lives in your pocket, or can. if you do develop an application that you want to sell, it's super easy to sell it and market it on the App Store. Okay? On other platforms, you're like, what, I'm going to put it in a box, or I'm going to make a website and people order it? No. Here, people have the App Store. Everyone who has a device has the App Store. They can just click, bam, you get paid. It's very awesome. And it has a pretty vibrant and big development community. I mean, obviously, Android developers aside, or not aside, this is a large development community. A lot of people working on apps for the iPhone. And so, you know, you're entering in an ecosystem where there's a lot of exciting jobs out there and a lot of exciting people to work with, okay? But besides building cool apps, learning to build cool apps, you're also going to learn about how to apply object-oriented programming in the real world. Okay, you've taken CS106A, CS106B, you know C++, you know Java, that's great. But now you're going to use that object-oriented programming learning to build apps that you could actually sell. And in fact, many of students who have taken this class in the past ended up putting their apps on the App Store. Okay, a very large number, dozens of them. So, so that's quite likely. Along the way, we're actually going to learn and review a lot of computer science technologies. This is a computer science course, okay? We're going to, in depth, do databases. In fact, object-oriented databases on top of relational databases is what we're going to do in this class. We're going to do a lot of graphic stuff, all this other stuff I have in here, multimedia, multi-threading. We do a whole week on building multi-threaded applications. So there's a lot to learn here in this class, not just how to build apps for this cool platform. So here's my really fast overview of what's in iOS. It's so big, I could take 2 or 3 lectures just going through each line item. I've tried to divide it up logically here based on closer to the hardware. So the stuff at the bottom is close to the hardware, and the stuff at the top is close to the end user. Okay? And I've just picked a sampling at each level. And these levels are not hard levels. They kind of cross over each other, et cetera. But a lot of people maybe don't know that the iPhone OS is basically Unix. Okay? It's Mach. It's the name of the Unix variant. It's a BSD variant. It's the same fundamental kernel that in OS X. And so you got a really powerful underlying operating system that provides a lot of primitives. So this core OS layer got a lot of stuff in there. You see some of the stuff I have in there, like sockets, and obviously you have a file system. Power management is a big key on embedded devices like these, because if you write an app, for example, that uses GPS all the time as you follow you around, it's going to eat up your entire battery really fast. So you have to learn how to, ask for the GPS coordinates on a reasonable, request basis, because you're talking about trying to listen to a satellite. That takes a little bit of energy. So the core OS layer has a lot of mechanisms for doing low-level access. Most of this stuff, not object-oriented, and you're not going to be writing very much code, if any, at this layer. The next layer up is object-oriented, and it covers a lot of that OS with object-oriented interfaces. Okay? So, for example, networking. There are classes in there like socket class and things like that, URL classes for opening up HTML pages. That's all object-oriented at this next layer up. But there's also non-object-oriented higher level things, like there's a SQLite database on every iPhone and iPad and iPad Touch. So you have SQL available. So you can do pretty serious database intensive applications on this platform. And then there's other pretty cool primitives at this layer, like Grand Central Dispatch, which is a mechanism for doing threading. That's really cool. We're going to learn that this quarter. And core location I have listed up here. That's like how to find out where you are using not just GPS, but also local wireless Wi-Fi stations, actually. You can look around and see what Wi-Fi stations are around and kind of guess where you are, which is pretty cool. And then even your 3G, by cell towers, it can figure out kind of to a general area where you are. So that stuff is all in this core services layer. I made media right here be its own layer because there's this device, iPhone or iPad, it's an iPod at heart. Okay, so all your music and stuff from iTunes, videos, watching movies and stuff like that, there's object-oriented APIs for doing all that stuff from inside your applications. okay? And so we're going to learn most of the stuff at this layer, how to record audio, how to record video even into your application, how to display video, how to draw graphics, obviously a lot of cool graphics drawing primitives, etc. So that's the media layer. But the top layer here, Cocoa Touch, that's the object-oriented interface to building applications. It's got things like recognizing gestures, swipes and pinches and all that stuff. It's got very powerful primitive objects like a web view, which is basically an entire browser in a little rectangular area that you can embed inside your application. Okay, entire with following links, everything, images, all that stuff. So core motion, which lets you use the accelerometer and the gyro in the new devices to figure out the position of your phone in space. Just enormous amount of stuff. I couldn't even, I mean, this is a tiny fraction, 5%. And it's also where the infrastructure for building the apps is. Okay, and we're going to talk about that in a moment too, that infrastructure. Just quickly covering the components of the platform, the development platform. So these are the things you're going to be using to build the apps. The things I showed you on the previous slides were the things that are on the device when you're running it. Here's the tools you're going to use. So you're going to use Xcode, which is kind of this all-in-one application that lets you do code editing, building, all that stuff, debugging in one place. There's another app, Interface Builder, that lets you wire up and build your user interface graphically without having to write very much code at all. Actually, in the next version of Xcode, Xcode 4, those two applications are going to be merged into one, Interface Builder and Xcode. We're not going to be using Xcode 4 this quarter. And then there's also a bunch of applications in a suite called Instruments that are for things like managing your memory, finding out whether you're leaking memory, analyzing the performance of your app. Why is my app running so slow? Really powerful tools. I wish we had more time to go into those. Again, maybe a Friday section, but they're pretty cool and pretty powerful. Again, new language to learn. It's called Objective-C. It's a strict superset of C. I'll be teaching you that language from scratch. I'll teach you everything there is to know about that language pretty much next week. Frameworks, this is what you might call in other languages, like in Java, it might be a package, you might call it, or a library. These are basically groups of objects, and there's a ton of frameworks, and we'll try to cover as many as we can this quarter. An underrated but really important component of this platform development is this object-oriented design strategy called MVC, Model View Controller. So that's what I'm going to cover in the next 25 minutes, and then we'll be pretty much done for today. Any questions about the platform before I go into MVC? It's pretty obvious. It's pretty early right now. You're kind of probably swimming a little bit in a lot of data, but it'll all become clear to you. So MVC, what is MVC? Okay, MVC stands for Model View Controller, and you can see up here I have a model, a view, and a controller. Okay, so what are those things? The idea with MVC is we're going to divide up all the objects in our program into one of these three camps. It's going to go in the model camp, the controller camp, or the view camp. All right? Now, what's the definition of those three camps? Okay? The model camp is, and I'm trying to summarize this in a single line of text so that you have a tagline for it, but it's basically what your application is, but not how it's displayed. Okay, so I'm going to use an example. You're building a video game, right? Shoot 'em up space game, let's say. Ships firing each other, blowing each other up, whatever. The model is where the ships are in outer space, how much damage a weapon does, what weapons are on a particular ship. Okay, the health of that ship, let's say. That's the model of your application. None of those things are what a ship looks like or where the ship is on screen. Okay, the model is where the ship is in outer space. It's not where it says on screen. So you could even imagine having a model like that where the interface is a command line. /shoot at ship 123, return. Ship 123 takes 5,000 damage. I mean, it would be simplistic and ridiculous, but there's nothing to do with UI in the model. It's just what your application is, okay? That's different from other applications, if you want to think of it that way, right? It's what your application is or stores or accesses that other applications don't do. So the model is very important to understand and to design so that you understand what your application is. All right? So what about the controller? So since the model is just what your application is, it's the controller that is how it gets displayed. So you might have a different controller on the iPad than you have on the iPhone. Why is that? Well, the iPad has more screen real estate. Maybe you can get 2 or 3 windows up at once on an iPad. Okay? iPhone, very small screen real estate. You want to use it very effectively. You're not going to put 3 windows up. You're going to have 1 window and try to communicate the information as effectively as possible. So the controller is kind of platform specific. All right? Now, we are going to try and learn to write applications where we might have 2 different controllers, but we have 1 application that recognizes what platform we're on and picks the right controller. Okay? We're also going to learn how to build controllers that might share code. Because you can imagine that iPad one might put up 3 windows, but one of the windows it puts up is the same window that's on the iPhone. Okay? Maybe slightly different. But they need to learn to share code. But still, they're all in the controller camp. Okay? Now, the view camp are your controller's minions. Okay? And by that I mean they are generic, reusable interface objects that your controller is using to do its job. Okay? Which is, it's responsible for how your model is displayed on screen. All right? Now, the reason you might ask, why isn't the view just part of the controller there? It's all the UI right there. Well, the reason is that most of the objects in the view, you didn't even write those objects. Okay? They came from Apple. They're buttons and sliders and scroll views and image views and things like that. You didn't even write that code. So they really need to be in a separate camp. Okay? Because the key to this whole thing is managing communication between the camps. And if someone else writes the code, like Apple writing those view codes, we need to make sure we communicate that with them in an effective way. So I've drawn up here a little marking. This is like, imagine a road. Okay? So these are road markings. You can see that down the middle I've got double yellow line. That means you cannot cross from either side. Up on the other way, I've got dashed line, which means you're free to cross over this line if it's safe. And then the solid white line means you can't cross here, but the traffic's going in the same direction. Okay? That's what a solid white line means. It's not the same as orange, like you cross this and you go to jail, or you get a ticket. But it does mean you don't just freely flow across that line. Okay? So what I'm going to talk about today is the communication across these lines, what it looks like, and how we use that to build applications which are understandable, manageable, and well partitioned. All right? And that's the goal of this whole thing. All right, so let's talk about this direction first. Now, an arrow on the end of a line means initiating communication in that direction. Okay? So here we're talking about the controller talking to the model, initiating communication with the model. Now, it might ask the model a question, and so the model is basically communicating back, but only in response. Okay? So the arrow means initiating communication in that direction. So you can see that the controller has a dashed white line towards the model. He knows all about the model. If you want to think of it in code circumstances, he can import the model's header files, at least its public API, right? So the controller has access to the model's API. He can send messages to the model all day long. It can send messages like, where's this ship? Give me the list of ships. Okay? It needs to be able to say that to the model because it's responsible for displaying those ships on screen in the video game. It needs to be able to ask the model pretty much any question the model is willing to publicly vend. All right? So that's a pretty free-flowing green arrow across the dashed white line. Similarly, this direction. Okay? The controller needs to be able to put the views on screen, set their attributes, tell them when to go off screen, group them together. It needs to be able to say anything it wants to the views. Okay? So the controller has pretty much unlimited communication to the view, to the objects in the view as well. And you notice if I put this little green word up there, outlet, as I do this whole thing, I'm going to put up a few key words that we use to refer to things so that we can have a common vocabulary. We use the word outlet to mean a pointer from the controller to a view. Okay? And we call that an outlet. Okay? So that just means there's an instance variable in the controller that points to the view that we can use inside the controller camp to talk to a particular view. And a controller will typically have lots of outlets, lots of pointers into the view. Okay? Next, across this line. Well, obviously, I think, hopefully you learned at least enough from your object-oriented experience that the model, which represents what your application is without UI, clearly can't be talking to the view. All right? And you really don't want the views talking to the model either. And some people will say, oh, no, that's okay. The view, I can have a custom view that knows about this model. Generally, we don't want to do that. And that's because we don't want to have too much communication across camps, so that when we're trying to figure out what's going wrong, why a view is not displaying something, we have to now go look in the controller for some things, and we're looking over in the model for the other things. That's confusing. Also, the model wants the flexibility to be able to change. What if we're doing a spaceship game and we introduce a new gravity model? Okay? So we have to change the API a little bit. We don't want to have to go rewrite our custom view necessarily if it's just responsible for drawing the ship as it moves around. Instead, maybe we change a few lines in the controller that interpret the information for the view. So this, I make a hard line. I do not allow communication between my models and my views. Okay? So double yellow line there. How about the view speaking to the controller? Can the view send messages to the controller? This, you might think, but sure, yeah, the view needs, to talk to the guy who's controlling the whole UI experience. But the answer there is sort of. All right? You do not want these objects in the view, which are generic objects like a button or a slider, also might be written by someone else like Apple Computer, okay, to be importing the header file of your controller. They can't. Okay? They're built generically. So we have to provide mechanisms for those objects in the view to communicate with the controller in kind of a blind way where they don't know what the class of that controller is, but under certain defined circumstances, they're going to communicate with that controller. Okay? So I'm going to talk about 3 different ways, which are the 3 primary ways that the view is going to talk to the controller. Okay? The first one is called target action. Okay? So the way this works is the controller basically hangs a target up outside its window, and then it hands an action out to the view that it's interested in hearing from, like a button or a slider. Then, when the button gets touched or the slider gets moved, this action gets sent to the target. So you can see by doing it this way, the view, the button, just knows it's sending some action to some target. It doesn't know anything about the class or the thing it's sending to or anything like that. And when it sends that action, actually, the receiver of the action can actually send a message back to the sender and ask it some questions. And you'll see that when we do our demo on Thursday, that it's often convenient for us to go back now and, a view sent us a message. We're going to go back and ask it some questions so we can figure out what to do. So that's called target action. And that's a very common way of having the view communication to the controller, initiate communication to the controller, but have it be blind. But sometimes a view needs to synchronize with the controller or get some help to figure out how it's supposed to do what it's supposed to do that's more complicated than just, I'm a button, I just got touched, or I'm a slider, I just got moved. And I don't know if you can read the little text there. Hopefully in this room you can. I don't know what it's going to look like on iTunes U, but the 3 little words there that object is desperately trying to send to someone is will, should, and did. Okay? And these, I put those 3 words because those are in 80% of the messages of this category that I'm going to talk about here. And they're kind of exactly what you would expect. Should means that this view object is trying to ask somebody, should I do this? Okay? So it's a web view and someone clicked on a link. Well, the web view needs to ask somebody, should I open this link? Is that okay? So that's a should kind of message. Will and did are, I'm about to do something, I'm a view, I'm about to do something, and I just did something. Okay? Because the controller might need to coordinate some activity. Right? So like a scroll view, let's say, you're scrolling up and down. Okay? The person puts their finger down, tracks up, scrolls up somewhere, and lets go. Well, the controller might want to hear the scroll position has moved to a different place. Now I need to put something else up on screen. And so the scroll view might send did scroll to location, whatever. Okay? So this mechanism we call delegation. Okay? And so there is an instance variable in many views called its delegate. And the controller sends a message to the view saying, I am going to be your delegate. Okay? Now, it's using a protocol in the object-oriented sense, so the view has no idea what the class is. All it knows is the thing that's setting itself as a delegate can understand messages like will scroll to, did scroll to, should, should open link, those kind of messages. Okay? I have another arrow up there that's pointing to this outer space, which is to say that there's other things besides will and should and did that get delegated. But you can think of this as the controller just letting a view know, hey, I'm the one you want to talk to when you need some more information about how to behave. Okay? Each view, by the way, can only have one delegate. So it's not like you can have multiple delegates. And if you want to have essentially multiple delegates, you have to have some delegate that's handing off these messages to someone else. Another thing, you see I'm flashing and making a lot of, shaking on the screen here. This is a very important point to remember. Okay? Views, these little guys in the yellow camp or the taupe camp or whatever color that is, they cannot own the data they display. Okay? Why is that? A couple of reasons. One, they want to be generic. So they don't want to be the kind of view that manages this huge data structure of information. Instead, they want to let someone else manage that, and when it's time to display it, they'll ask for some help to give that data to them. Okay? Second reason is for performance. Okay? The iPhone screen is very small. It can only show a small amount of data. If you've got a space shoot 'em up game, you can only see a few ships at a time. Okay? You're not going to see 40 ships on the screen at the same time. So you do not want that view to even worry about those 40 ships. You shouldn't even see them. It certainly doesn't want to have a big data structure with them in there. Okay? The data, so how do we manage this? Views not having their display. We essentially have another protocol which is called a data source. So it's similar to delegate, but it's called data source protocol. And its little arrows are messages like count, give me the count of items. Let's say you're displaying a list, which is very common on the iPhone to have a list, like a list of addresses, a list of iTunes songs or whatever. So how many are there? And then give me the data at row 7, give me the data at row 8. So you can imagine even if you had a list of 20,000 songs, you're only seeing 7 or 8 at a time. So it's very highly performant to have that list view only asking via its data source. So we'll see that a little bit too, where we have data sources for views. And when you design your own views, in homework number 3, you're going to want to use a data source to get your data. Okay? What's next? Why is it that the data source is not the model? Some people ask. All right? The reason for that is the same thing I was talking about before. The controller's job is to interpret the information in the model for the view. Okay? The view is trying to be generic. It wants to have generic objects that aren't specifically tied to any particular implementation. And so the model wants to have very specific implementations of its model. The controller is the one that bridges that gap between genericness on the view side, specificity on the model side. Okay? So that's why we do not make the model be our data source. It's the controller, or some object that the controller designates that's in the controller camp. So last question. Can the model talk directly to the controller? Okay? Again, hopefully this is obvious. No. Because the model is not a user interface group of objects. It doesn't know about user interface, and the controller's whole job is user interface. So we do not want the model communicating directly to the controller. However, sometimes things change in the model. Okay? A spaceship moves, or it gets blown up, or something else changes. A new player joins the game. So what happens? How do we let the controller know, or let the UI of the model know that things have changed? Well, the SDK provides a mechanism which I describe as kind of like a radio station. Okay? It's called notification, and there's another mechanism called KVO, key value observing. And it's a simple mechanism that allows objects to broadcast notifications. Basically say something has changed. Pay attention to this. And they can pass some information about what changed. They could pass a pointer to themselves, which is okay for the controller to follow because it's allowed to do it, to talk down that green arrow. So objects like the controller, you see it up there animating, they just tune in to whatever changes are interesting to them to do their job. Okay? So that's a mechanism whereby the model is able to communicate its changes, etc., without having to know anything about the UI. Okay? Now some UIs might react to those changes right away by drawing something different on screen. Other UIs, like the command line version of it, maybe do nothing. Maybe they print out something that says ship was destroyed, you know, or maybe not. But that's kind of up to the controller of that particular user interface. And I use the command line. Obviously, you would never do that on these devices. I use it as an extreme example, okay, just to draw a distinction between how the model knows nothing about the UI. So that's pretty much it. One other question people sometimes ask is, well, can a view just sign up for that radio station? Okay? But again, that's just like setting a model to be your data source. The problem is you're having your view now not be as generic. It's very specifically tied now to your model, and it's just as easy to have the controller manage it. It sounds like, oh, that'd be a lot of extra code. Then actually, it's usually not very much extra code at all. Okay? And it's important code because when you're debugging it, trying to figure what's going on, you know exactly where to go in the controller. Okay, so this is great for a simple little application, right, that has a simple model and control, but you wouldn't want to build a humongous app with all kinds of screens and preferences panels, and you know, you got your space shoot 'em up, you're going to a space station, you're on board. You don't want all that in one gigantic, you know, controller or suite of controller objects. So when we build applications, we combine these MVCs into multiple MVC groups like this. Okay? So here you can see the little MVCs, and that some controllers, like the one up in the middle, its view pointers are pointing to other controllers of MVCs. Okay? We are going to be doing this all quarter long. So this is not considered, oh, this is only for the most complicated apps. This is, you know, pretty straightforward. And the thing about the iOS SDK, it makes it really easy to do this and really easy to understand where these boundaries are. And if you look at this picture, pick out any group, any camp on here, and you'll see there's not very many arrows going in and out of any one node. That's what object-oriented programming is about. Okay? It's about keeping the number of arrows in and out to a manageable, understandable, documentable number of other interactors. Okay? That's why when we write good object-oriented code, the most important thing we're trying to understand is what's the responsibility of this object. And we're trying to define an object's responsibility so that it's understandable to other people reading our code. Okay? And if we pick our object boundaries correctly, the amount of interaction it's going to have with other objects is going to be pretty minimal. Does that make sense? So we're trying to get to here. The alternative is something like this. Okay? Where you got objects all talking to each other all over the place. You know, take a look at the controller in the upper right-hand corner. It's got, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different things it's communicating with. So that's going to be 11 different kind of interfaces it's going to have, and keeping track of that is just next to impossible. So we definitely don't want to do this. Okay? We want to keep our boundaries well defined. So one of the evaluation criteria that's going to be on your homework is defining the boundaries of your objects very clearly and not putting the wrong code in the wrong camp. So I don't want to see code that's really your model in your controller. I don't want to see code that's supposed to be in your controller pushed down into some, you know, view that's kind of weird, has weird semantics. And I do want to see you creating views that are reusable, okay, that are generic as possible. Okay, I don't want to have a lot of views that only would work in this one application. I'd like to, if possible, see you create a view that you could use in another app. All right, because one thing you'll find about people who write applications for the App Store and who are successful, it's never one app. Okay, they write one app, they're successful, then they write 5 more apps because their company gets the little successful name and they're able to reuse that code. Okay, but only if they build their system to be reusable as well. All right, so that's it for MVC. On Thursday, what I'm going to do is I'm going to put these same MVC slides up, and I'm going to talk about how we're going to build this calculator, okay, using that model. All right? So I'll show you where the actions, the targets, all that stuff are. It's almost all going to be me typing into Xcode. So you're going to see Xcode, how to create a project, create new files, create a class, add methods. You're going to see all that stuff. I am going to have a few slides at the beginning to just almost like reference, like the textbook I was saying in the class, that show you how to define a class in Objective-C, what the syntax is, all that stuff. And at the end of the day on Thursday, your homework is basically going to be to reproduce what I do in class and then add some stuff to it. Okay? But don't worry about coming to class on Thursday and like, oh, I got to furiously take notes because I got to reproduce this, because I'm going to give you a handout that basically describes step by step, mouse click by mouse click, how I built the thing. Okay? On Thursday. So don't worry about it too much. But to see it done, it's a lot easier to reproduce than to try and read through this document with a lot of open this window, click OK, that kind of stuff. It's a little slow going. Friday's section is installing the SDK using the debugger, show them how to use the documentation, how to get at the class documentation, etc. And then next week, I will teach you Objective-C from start to finish in the 2 lectures, again with a demo on Thursday, including the foundation classes, which are arrays, dictionaries, strings, things like that, which are not part of the language in Objective-C. They're part of a framework called the Foundation Framework, but they might as well be part of the language from your point of view because they're fundamental. As you can imagine, building something without an array, pretty much impossible. And you don't want to use C arrays to put objects in. You want an object-oriented object array. We'll talk about the difference between dynamic and static typing because you're used to C++ and Java, which have C++ to a much less degree, Java to a little more degree, but Objective-C to an extreme degree allows dynamic binding. In other words, what code gets executed is not determined until the message is actually sent at runtime. Okay? And that gives you a lot of flexibility with protocols like delegates and data sources and stuff. You can abuse it too, and you can get into a little trouble with programs crashing at runtime because you send a message to an object that doesn't understand that message. So we'll talk about that and how we manage that and how we let the compiler help us not get into that situation, etc. And then the very big topic of memory management. The applications on the iOS are not garbage collected, so you've got to manage the memory yourself. It has some pretty simple, straightforward mechanisms for managing it, but it does require you, as you're writing code, to think about it. So memory management is something you need to think about. So we'll talk about that next week as well. So that's it for this week. Thank you for coming. We're a little short, luckily, because I have to go. And we'll see you on Thursday.
For more, please visit us at stanford.edu.